we will talk about the SN2 reaction. So please give a headline. Yeah, SN1 we discussed. SN2 we will do now. Substitution. You were there in the last class, no? I explained, right? One nucleophile replaces the another, right? And in SN1, I told you, know, it's a two-step reaction where you get carb cation as an intermediate. That is why rate of reaction is 3 degrees the fastest, then 2 degree, and then 1 degree, right? And I also discussed because the carb cation carbon, this carbon, the carbon, right? It is sp2 hybridized, and because of its sp2 nature, the attack happens from front also and rear also. When it attack happens from the front, where the older nucleophile was present, it's called retention. And from the reverse side, the rear side, the opposite. Yes, that's called inversion. And when both are found in 50-50%, we call it as racemic mixture. Okay, you're clear, no? Now, just and also what I discussed, the all the SN reactions are exothermic in reaction nature. That is why it's more favored at low temperature, right? Also, we use polar protic solvent. Polar means which breaks the carbon and halogen bond. Protic means it captures. It doesn't allow it to. I hope you now recall everything, right? You got it, no? You have the notes with you, right? Okay, so everyone, online, am I audible to everyone? Can you all see the board? Whatever I'm writing, is it clear? Okay. So guys, please write the headline SN2 reaction. Okay. SN2, that means SN2 reaction. Hi Arnav, how are you? Good evening. So SN2 reactions should be the headline for today. And SN2 means nucleophilic substitution bimolecular. Nucleophilic substitution bimolecular. All right. Guys, now please see here that why it's called bimolecular. Okay. Yes, Shaurya. Yeah, yesterday in the last class we discussed SN1 reaction. Today we are doing SN2. So why it's called bimolecular? 2 means bimolecular, okay? Because in SN1 we discussed rate of reaction was only depending on concentration of alkyl halides, haloalkanes. But in this case, the rate of reaction it depends on it depends on both. Yeah. So Dia, take a quick note. We have started SN2 reaction, okay? Bimolecular. And rate of reaction is depending on alkyl halide as well as nucleophile. Remember, SN1 reaction was not depending on nucleophile. So what is 1 plus 1? What is the molecularity? 1 plus 1, 2. 2 means bimolecular. Okay? Now, remember, all SN reactions are exothermic. That is the similarity between SN1 and SN2. So this reaction is also exothermic. Exothermic means what will be the delta H? Delta H will be negative, right? So reaction is favored at, according to Le Chatelier's principle, reaction is favored at low temperature. See, later on you will study one reaction which is you will study, it's called electrophilic substitution. And you know what? Interesting part is the electrophilic reaction and nucleophilic reaction, they are competitive, like India and Pakistan. Okay, how they are, competitive, right? In a cricket match. Okay. Similarly, electrophilic reaction and nucleophilic reaction are always competing with each other. So, who is the deciding factor that what reaction ultimately it will be? Will it be nucleophilic or electrophilic? It depends on temperature. If you keep the temperature low, it favors nucleophilic. And in electrophilic, if you keep the temperature a bit higher, then it will go electrophilic. So major product will be formed in low temperature as per electrophilic and nucleophilic. And at higher temperature, it forms electrophilic. However, later on, I'll tell you those things, okay? I'm just giving you idea. That is why again and again I'm mentioning this point. Whatever point I'm writing has a important requirement, okay? That is why. So I'm not simply writing because it's just a theory and you write it down, okay? It's required because I try to give minimal theory, okay? And if I've written this, it is important, okay? Online, is everyone clear? All right. Now, remember SN1 reaction. See, parallelly, your mind should think about SN1, okay? So in SN1 reaction, it was a two-step reaction. Here it is just a single step reaction. You don't have two-step, single step reaction. In SN1, you had the carb-cation intermediate. There is no carb-cation, no carb-cation intermediate. There is no carb-cation intermediate, okay? Now you might wonder, so you might wonder, okay, then what will be the driving factor? Because in SN1, it was stability of carb-cation, 3 degree, 2 degree, and 1 degree. But what would be the factor here in this case? So write it down, steric hindrance. Rate rate of reaction is inversely proportional to the steric hindrance. Yes. What are you saying, Avantika? On the top, where? Tell me. ALC. Yeah. Oh, acha, acha. I get it. I get it. You're talking about this, right? According to LC Lee Chatelier's principle, okay? According to Lee Chatelier's principle. You got it, no? What Lee Chatelier says that if you disturb the reaction in equilibrium, it will shift in that direction, either forward or backward, to undo or to negate the effect of the changes made. You got it, no? Because reaction is exothermic, to undo the effect, because equilibrium will get disturbed, it shifts, on that side where the temperature is low. I I hope it's clear, right? You got it, no? Avantika, you're clear? Okay, now. So, yeah, I'll explain. Steric hindrance means bulky group. Bigger the group, slower is the reaction. Smaller the group, faster the reaction. That is the rate of reaction depends on. Now, if I give you, now guys, please see this. Now, if you observe what I have drawn, 1 degree, 2 degree, and 3 degree alkyl halides. Tell me who is the bulky, who is the most complicated one? 3 degree. Who is the simplest one? So that means in this case, the rate of reaction is 1, 2, and 3, just reverse of SN1, which was 3 to 1. So the order of reaction is 3 degree is the least, then 2 degree, 1 degree is the fastest. I hope it's clear. Rate of reaction, ROR. Okay, Shreya, you got this? 3 degree, 2 degree, 1 degree. Okay, 1 degree will be the fastest. Shubham, you got it, no? Just the opposite. All right. Now in SN1, we used polar protic solvent, which was breaking the bond and capturing the nucleophile. Here, just polar, not protic. So here we use polar aprotic solvent. What do we use? Polar aprotic solvent. And just to demonstrate that, I will show you. Please see this. This is the CX bond. So because it is polar, it will break it. Once it breaks, then this is removed, partial positive, partial negative. So when halogen is removed, old nucleophile is removed, right, from the carbon. There will be aprotic, means it won't capture it. So write it down. After breaking, this is the polar, but no capture. No capture, that is aprotic. When it captures the removed nucleophile, then it's called protic. Because it doesn't capture, it's aprotic. Now, what are the examples of this aprotic solvent? So let's see the examples. So we have certain example. The first one is, it's called acetone. Second one is DMF. It's called dimethyl formamide. And DMSO, dimethyl. So only the names are required here. Sulfoxide. Still, if you want the structure, just remove this CO, put SO. It becomes sulfoxide. And if I put a amide group here, it becomes dimethyl formamide. But structure are not important. So just remember on the names. Short form and full form, okay, both. So these are the examples. So guys, what was the order in SN1? 3, 2, 1. What was the order in SN2? 1, 2, 3. So it means if you have a 1 degree alkyl halide, you will say, will it go SN1 or SN2? Yes, if it's 1 degree, SN2. Very good, Tanishka. And if it is 3 degree, then what will you say? What it will favor? SN1. It means 2 degree can go both. 2 degree can give SN1 also and SN2 also. Then how do we decide? It will be decided by the solvent. It means an important note you all should write. Wait. So guys, I will just make an important note here. See, 3 degree alkyl halide will prefer SN1. 1 degree alkyl halide, you will say it will prefer SN2. Correct? But 2 degree can form both. It can give SN1 also. It can give SN2 also. How will you decide when it will give SN1 or SN2? So when you have those examples of polar protic, then SN1. What were the examples of polar protic solvent? H2O, ethyl alcohol and acetic acid. And if you have examples from polar aprotic solvent, then SN2. Advitya, you got it now? Okay. So remember, for 1 degree and 3 degree, we see the degree to decide SN1, SN2. But for 2 degree, because it can go anywhere, we check the solvent. I hope it's clear. Pranav, perfect. And Ritik is in the class. Oh, acha, he's went for school trip. All right. Okay. So now next up, Tanuj is there, no? Tanuj is there. Tanuj, you got it, no? Okay. Now, hmm. See, it will happen. See, what Avantika is asking is that in 3 degree, what if I put aprotic solvent? See, solvent we see later. First, we see degree. We prefer according to degree wise. So, even if it's aprotic, reaction will be difficult, but it will happen though. And what it will happen? SN1. So, Avantika, first we check the degree, then later on we check on the type of solvent. Okay. So, the reason primarily is stability of Carcatan. Here the primarily reason is steric hindrance, or you can say bulky group. Uh, Bulky. Okay, sure, you clear now? Okay. So guys, today we will be doing a lot of questions on SN1 and SN2. Okay. Now, next up, what we will do, yes. Now I have to tell you some more three things. Guys, now let's write it down one more thing. Attack is only possible Attack is only possible from rear side. So only retention product is formed. Sorry, inversion product is formed. So only inversion product is formed and no retention. This is super important. Write it down. I will tell you why this happens. So remember, only rear attack is possible in this case. Okay, you might ask me why. Say in the previous case, because of polar protic solvent, we broke the bond and we captured the nucleophile. This time, we are not capturing it, only breaking is happening. So the old nucleophile is still there and all the reaction is happening in the single step. So it is not possible for a new nucleophile to come from the front. Is it clear? Because still the old nucleophile is there. So new nucleophile and old nucleophile will have a huge repulsion and reaction will be not possible from the front. Now I'll show you the mechanism, you will understand it better, okay? So write down this, then I'll show you the mechanism. All right. Hmm. Because it is a single step, keep that in mind, only one step reaction. So how and for the example to explain the mechanism, which degree ideally you should keep? 3 or 1? Yes, so we'll take methyl chloride example. So take this example, methyl chloride. Guys, you don't have to be, worried about this, what I am drawing. It's simple methyl chloride only. Just the way I am representing is different. I'm trying to show a 3D module. So wedge and dash. Wedge is towards you, dash is away from you. Like tetrahedral. You got it, no? So this structure is called wedge. And this is dash. Got it, no? So now when we add, so guys, what do we add? Let's say we are adding KOH. What are we adding? In the presence of acetone, polar aprotic solvent. So from KOH, what nucleophile will come up? OH minus. Now see what will happen. This bond will break. This is the front side, right, where the position of old nucleophile is there. It's called front. So the bond is breaking and the new bond is attaching the new nucleophile from the rear side at the same time. Okay. So at this point of time, it may look like, at this point of time, it may look like, wait, it looks like the carbon has 5 bonds, but it's not true because it is a transition phase. It just shows two things at one time simultaneously. Breaking and attachment both happens at the same time. Okay, so it is called transition stage. It's very short lived. You know how long it lives for? 10 to the power minus 6 seconds. Got it? And finally, so understand, because the attachment and breaking happens at the same time, that is why when one nucleophile is still there, another it won't allow. That is why no retention, only inversion. Online, is everyone clear? Sorry, you got this? What I'm saying, because the attachment and breaking happens at the same time, we are using polar aprotic solvent, right? So this old nucleophile won't allow the new nucleophile to attack it from the front. Hence, the rear attack happens. Clear, no? And that is why we don't get retention, only inversion. So final answer will be something like this. And this is how we got alcohol. So alkyl halide changed into, no, 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 no. It is not participating. Acetone is just a solvent here. There, water was participating also, and it was a solvent also. You got it, no? Diya, Arnav, guys, did you get it? Ananya? Okay, all right. Guys, okay, is everyone done with the mechanism? Okay. Done, no? Okay, so we'll do some questions now. Just give me a second, I'll write the questions. Meanwhile, please revise everyone SN1, SN2. I'll write the question in 2 minutes. Yes. That is why, yeah, front attack is not possible. That is why you get only inversion product, okay? Avantika, you clear, no? Only inversion product will be possible. Okay. So, guys, I'll just draw the two questions or two options. Guys, there are two questions. You have to identify who will give faster SN2. Okay, first solve it, then tell the answer. Okay, there are two questions, separate questions. Okay, in between them, you have to decide who will give faster SN2 and why. Second one is very easy. First one you have to tell. Okay. All right, is everyone done? Online, guys, is anyone done with the answer? Kindly confirm. Okay, okay. Who has got it? Okay, okay. Sure, I got it. Arnav also got it. Okay, so everyone, please tell me what is the answer for the first question and why? Mm. Iodine one. Iodine will give faster reaction. Now my question is why? Yes. Yes, absolutely correct. Everyone said correct. So guys, understand both are 1 degree first of all, right? Both are. So there it's a tie. But if you see the size of carbon and iodine, iodine size is bigger, right? So all of you write it down. Size is inversely proportional to bond dissociation energy. Avantika, you're clear? Because when size is when size is more, longer will be the bond length, and it is easy to break. So that is why iodine is a very good leaving group. So write it down. Iodine is the best leaving group. So order of reaction is iodine, then bromine, then chlorine, and then fluorine. Please take a note of this. Iodine is the best living group. Clear for everyone? Now, second one is very easy. Shaurya, give me the answer. What is the second answer? Yes, this is the fastest because it's 2 degree less bulky. This is 3 degree more bulky. This is more bulky. All right. So, guys, I want you to solve this question now. Guys, write the answer. What will be A? What will be B? Question is identify A and B. Find A and B. Guys, find A and B. Guys, tell me what is the answer? Anyone who got A and B? Yes, Tanishka, you got it? Okay, Avantika, you will tell B. Tanishka, you tell A. Tell me the answer for A. Wait, let's do one thing. You can go and write on the board. Yeah, you can just keep it on the side, next bench. Yeah, so you can solve it on the board for the A option. Avantika, after that, I will check with you for B. Hmm. Okay. Butane to all. Okay. Inversion. Okay. Good. Yeah. All right. Okay. How many people got this same as Tanishka got it? One, two, three. Pranav, what is your answer? Yes, Avantika, you're right. Tanishka, there is a slight mistake. Yes. What is that slight error is? You can, you know, right, there is going to be a SN2, right? Correct? You also know OH will be attacking the nucleophile, right? Plus, you also know inversion will form. Then what mistake happened is it is on wedge. So wedge opposite, it will turn into dash. So you need to show it like that. Okay. So answer will be in the dash form. Rest everything concept wise, it's correct. Okay. Presentation wise, you have to improvise. So the answer will be this. That's all. The wedge turns into dash. So guys, what is the answer for the B? Avantika, what is the answer for the B? Uh-huh. Yeah, very good. So the B will have two answers. One will be wedge, one will be dash. Shubham, you're clear now? Okay. Shaurya, Pranav. Okay. So you can see that. Done? Okay. So let's to discuss few more questions. Guys, the question is pretty simple one. And question is, let me write the mechanism, write the mechanism of the following SN1 reaction. Write the mechanism of the following SN1 reaction. So it is CH3 4 thrice CBr gives aqueous NaOH to OH plus NaBr. So guys, one reaction is given, they are asking you to write a mechanism. First of all, tell me, will this be a SN1 or SN2? Yes, why it is SN1? It's not because of the water first. Avantika, check the degree. First, you will see the degree. Later on, anything else, okay? So, because of the 3 degree, so all of you write a two-step reaction now. First, form the carbocation, then attack the nucleophile. So, what nucleophile will be attacking from NaOH? Huh? Yes. So, all of you write a reaction. Ananya, do you have any doubt? Okay. So, solve this question. I'm waiting for your answer. See, these all questions what you're doing are board exam questions. Okay. And after this coming weekend also we will do IUPAC, the second part, first part of IUPAC we have done. And then from the next weekends we will do questions from the entrance ke liye, okay, from this chapter. As we finish one chapter or some topic, based on that we will do entrance questions. These are board questions. These are not entrance questions, okay? Shreya, you have missed some classes. Hope you have gone through the recordings. Guys, let me know if anyone done. Guys, after that, there's one question. There's one question. Why racemic mixture is optically inactive. Why racemic mixture is optically inactive? I will discuss this question. You don't have to solve it. You have to just finish the first one. Okay, can I check the notebooks? Is everyone done? Yeah, first step, formation of carb cation. Second step, attack of nucleophile. And you have shown both. Yes, good. Correct. Huh? We need a more proper presentation. Okay. And, why still there is a carpet if the nucleophile has come up? And why you have written this like this only? You should have expanded it, no? You got my point? Yeah. Pranav, can I see your answer? Not sure. It's almost there, but still almost there to nowhere. Is your answer? Ah, that's fine. As long as it's neat, there is no problem. Yes, it's a correct answer. Hmm. शुभम क्या चल रहा है? Okay. Yeah, I'll talk about it. Okay, I have to tell you few things. I have to tell everyone few things. First of all, we need to understand what is optically active and optically inactive. Then we will discuss on this. Anyways, I'll come to jump to this question a bit next. First, let me have a discussion. Online, how many people got the answer? Guys, raise your hand. Who has already wrote the mechanism? Avantika wrote it. Only one raised hand. Advait. Okay, good. They also got it. Advitya. Ananya, okay. Tanvi, Tanuj, Shaurya, what about you guys? Shreya? Okay, so I will explain it right now. Shaurya, you are clear, right? It's SN1, it will be because it's a 3 degree, right? If okay, now see how do we expand it, okay? This carbon has three methyl group, right? So one methyl here, another here, another here. Got it? And it has a Br. That's how we open it. Got it now? So first thing what will happen that there is going to be a bond cleavage and formation of carb cation. So we will get CS3C, CS3, CS3 plus and Br minus is removed. This Br minus will be captured later on. That's a different story. You already know that. This is step one, formation of carb cation. Step two, step two, mein what will happen? Now there will be attack of nucleophile. So from this, what nucleophile will come up? OH minus. OH minus. ठीक है? So when OH minus will attack on this, so you will get two products. There will be attack of OH minus like this. Correct? One from the front, one from the rear, and one from the. So the kind of answer you will get, it will be like this. Plus another answer, and that is OH, CS3, CS3, and CS3. I hope it is clear. SN1 already you know, right? In SN1, it's a two-step reaction, two products, both retention and inversion. Because we use polar protic solvent, right? It captures, so attack can be possible from both the ends. Retention also. So where the old nucleophile was, at if the same place new nucleophile came up, it's called retention. And if it comes opposite, it's called inversion. And when they both are formed in 50-50 amount, it's called racemic mixture. Now the question is, why racemic mixture is optically inactive? First of all, understand what is optical activity. Okay, then only you can answer this question. So all of you give a headline, optical activity. Guys, in chemistry, whenever the term comes optically active, it means it's talking about rotation of plane polarized light. Okay, polarized light either clockwise, either clockwise or anti-clockwise. So optically active solutions are such solutions who rotate the plane polarized light either in clockwise or in anti-clockwise when you pass it through them. It means, for example, if I say the plane polarized light, what is plane polarized light? So see, this is how we represent PPL in two direction. Do you see that? This is how we represent plane polarized light. Got it? And when you pass this light through a beaker, which contains optically active solution. Let's assume there is some solution in this beaker which is optically active. Okay? So when this light passes through this beaker, so what happens? You get two possibilities. Either the light gets rotated to some angle, either clockwise, or another possibility is it may get rotated to, okay, anti-clockwise. I hope it's clear. Clockwise or, yeah, tell me now. Yeah, I will tell you the conditions what is optically active. Okay. Compounds are optically active. Okay. Optically active means when there is a chiral center. When there is a chiral, now you might ask me what is chiral center? Okay, when there is a chirality. Chiral center means that is asymmetric carbon. What do we call? Asymmetric carbon. Now you might ask me, sir, you are confusing me a lot. Tell me in simple words, what is it? Okay. So in simple words, where a 10th grade student can also understand, and that is when a carbon has all four bonds different. When the carbon has all four bonds different, such carbon is called chiral carbon or asymmetric carbon. Take a note of it. And if in the compound you have such carbon, they are called optically active. Is it clear? Understood, everyone? So what does optically active solution do? When you pass a plane polarized light, something like this, they will turn it into a clockwise direction or anti-clockwise, either one of them. Details you have to learn in a chapter called biomolecules, okay? In carbohydrates, all right? But anyways, I'm just telling you the basics. Okay, got it, no? Online, is everyone clear? Kindly confirm, guys. Okay. Okay. Did everyone wrote it? Guys, please confirm. Did you all write it? Optical activity and everything. Online? Yeah, what are you saying? Yeah, optically active asymmetric carbon or a chiral carbon means all four bonds of a carbon should be different. Okay, you can see this carbon has all four bonds different. All four valencies are different. Avantika, do you need example? Now I'll give you one example, guys. Do you see this? You might ask me, sir, what is this? This is a amino acid. It is a amino acid. You can see, Avantika, this carbon is chiral. In textbooks, chiral carbon are marked as a star. So that is why I put a star. Okay? Star means chiral carbon. Okay? Avantika, you're clear? No, all four valencies are different. Guys, got it? Okay. Chalo, I'll give you a question now. Identify, identify the number of chiral centers. Identify the number of chiral centers in the given compound. Shaurya, you understood the meaning of chiral center? Okay. Now I'm going to give you a question. Question is, I'll give you a compound and you have to see and tell me how many chiral centers are there. Guys, identify now. I want you all to look at it and tell me how many chiral centers are there. And by the way, this is a structure of glucose. This is a structure of, what is the molecular formula of glucose? C6H12O6. You can check. It is C6H12O6. It's glucose. Okay. Now, let's see how many people will get this. You have to check. So, out of six carbons, how many are chiral that you have to check? One, two, three, four, five, six. How many? How many carbons are such carbons where all four valencies are different? Just check. Okay. Tanishka, you got one chiral, right? I'm just recording everyone's answer. Okay. Tanishka has got one answer. Okay. Now, Shubham, what is your answer? Okay. Shubham also has one. And you tell me. I just missed your name. Shreyan, right? Yes. What is your answer? Shreyan also is in club one. And Pranav? Okay. And what about the other Pranav? Okay. Pranav, both Pranavs, two into Pranav, they all have same answer. And Surya, right? Yes. Surya has three answers. Something new. Prem, eh? None of them is what? One, two, three, four, five, six. How many? Zero. Acha, you're telling chirality is not there. Okay. Prem answer is zero chiral. Okay. And online, let's check with everyone. Advait, what is your answer? Advait also is in one. And Pranav, okay, he told. Ananya, what is your answer? For Ananya also it's one. Okay, and Advitya. Oh no, Advitya. Why you said one? I was expecting you will tell something different. Okay, Tanvi. Okay, uh, Tanvi says three. Finally, Surya, you have got one. You know, voter. Okay, and Avantika. Avantika got two. Okay, this was the first time someone said two. Okay, and Arnav. Arnav, what is the answer? How many chiral centers? Okay, Arnav got three. Okay, and Tanuj. Tanuj, what is your answer? Tanuj, you got three. Okay, Tanuj is getting three. Shaurya, what is your answer? Shaurya also got one. Okay, one people are making majority. Diya, what is your answer? Okay, Diya also got two. And Shreya, what is your answer? Okay, Shreya also says one. Now, first of all, two has got the. Anyone wants to change any answer or something? Okay. Now, I think Tanishka is changing the position from zero. Okay. Tanishka also says zero. You also zero. अरे ठीक है अब हो गया let's leave it. Okay. So guys, first of all, the highest, the least vote came to zero. Okay. The least is in zero and two. So let me tell you, zero and two both answers are wrong. It's neither zero answer nor two. Okay. Then second highest vote, came to three. Three is also a wrong answer. Okay. So people who got one, their answer is also wrong. This also is a wrong answer. Okay. So guys, did you people understood six is also a wrong answer? Now something will be there, right? However, five is also a wrong answer. Yes, 4 is the correct answer. First of all, tell me one thing. Did you all understood what is chiral carbon is? It has all four valencies, different. So if I look at the first carbon, okay, if I see the first carbon, one side it has a ketone, the other side it has a hydrogen, Third side it has these carbons, right? Fourth side there is also a hydrogen, right? It means this carbon cannot be chiral because two hydrogens are there. So first carbon is gone. It's out of the list. Now, if I look at the last carbon, the sixth carbon, one side it has this carbon. Oh, my bad, yes. Yeah, not because hydrogen. You made a right point. It's because its two valencies are occupied by oxygen. So that is why it can't be the answer. Okay, my bad. Yeah, in the last carbon, what you will see, there is a carbon chain it has, but there are two hydrogens, right? So that is why last carbon also can't be the answer. It is eliminated. If I see the second carbon now, in second carbon, what is the valency? X is this, right? This is Y, correct? This whole thing is Z, and this whole thing, whatever is there, all four are different, right? Guys, getting it what I said? So that means second carbon is a chiral. Similarly, third also is a chiral because it has all of these and all of that. And this is different, that is different, right? So similarly, this also is a chiral. Understood now? So answer is four chiral centers. Now you have understood the true meaning of chirality. Okay, Shaurya, now you understood? See, Aditya, the definition of chiral center is all four valency needs to be different, but this carbon, the top carbon, has only three valency. So that is why it's not. You got it now? And if you see the last one, if I draw the last one, above it has all those carbon chains. One side it has OH, but it has two hydrogens. Do you see that? So they became same. Same, gone. That is why last one is also not the chiral. I hope it is clear. Okay. Ananya, you got it now? Dia? Okay. I was expecting at least one student will say four. What? You're counting majority, one, two, three, four. Okay. So let's talk about the guys. The next question. Okay. No, we are not done with the previous question answering actually. Now you have understood. Now you have reached at that level where you can understand this question because you know optical activity. They are asking why racemic mixture is optically inactive. Optically inactive means why the mixture is not able to rotate the plane polarized light. So answer is very simple. Racemic mixture is a mixture of two forms, retention and inversion. So if and they both are in equal amount, right? Racemic mixture means one is a retention form, one is a inversion, and they both are in equal amount. So if one is trying to make clockwise, another will try to make it. So overall, no rotation. That is the answer. Is it clear? So guys, write it down. Racemic mixture is a mixture of retention and inversion compounds in equal amounts. So they both will have equal and opposite rotation, and hence overall net rotation is zero. That is why optically inactive. I hope it is clear. Avantika, did you get the answer? Okay. Not particular, yes. Only thing is they both are opposite, right? So their rotations will be also opposite. So it's like one will be dextro, one will be levo. So overall net rotation will be zero. Is it clear, no? Avantika, you clear? Okay. So guys, now we will do the next question. Yep. Faster towards faster towards SN1 reaction. So, oh my bad, not SN1. It's SN2. CH3, CH2, I versus CH3, CH2, Br. Okay. Second one, Cl versus CH2Cl. So guys, solve this question now. Then I'll give you the last question. Okay, first let's discuss this one. Then I'll give you the last question. Okay. Guys, so tell me what is the answer for the first one? First one is very easy. Iodine, right? Because iodine is a very good living group. So this is the answer, right? The reason? Good living group due to large size. Due to large size. Is everyone clear on this? Greater the size, easy to leave. Easy to break the carbon halogen bond. Now, what about this one? Yes. Second one or first one? I'm getting two different answers. First one is basically 2 degrees. This one is 1 degree. So answer is that's all. There's no doubt about it. Clear for everyone? All right, guys. So let's solve. Yeah, any doubt? I heard someone is asking any doubt. All right. All right, guys. So let's have the last question of the day. Okay. So they are asking arrange the following. Arrange the following in increasing order of their reactivity towards SN1 reaction. All right. Increasing, remember, many times students get the right answer, but they don't focus on word increasing. They do decreasing. So be careful. They are asking increasing. Now your options are 2 bromo, 2 methyl butane, comma 1 bromo pentane, 2 bromo pentane, and oh wait, 2 bromo 2 methyl butane, 1 bromo pentane, and 2 bromo pentane. Second one, 1 bromo 3 methyl butane, 2 bromo 2 methyl butane, and 2 bromo 3 methyl butane. So guys, you have to solve these two questions. First, convert the IUPAC naming to structure and then arrange them in increasing order. See, 1 bromo 3 methyl butane, 2 bromo 2 methyl butane, 2 bromo 3 methyl butane. Yep. Guys, try this one. And yeah, this question came in 2023 board exam. Okay, got it? Last year. Huh. Methyl butane. Wait, 2 methyl butane. This is butane, 2 methyl butane, okay? Remember, it's SN1, carb cation stability, right? Okay, Tanishka, you done? Good. How many people got it? The first one? All right. Okay, Avantika, you have got it. What about others? So guys, 2 bromo 2 methyl butane. So first of all, there is a this is the first question I'm solving. Everyone match your answers. Second one is 1 bromo pentane. Got it, no? And next what you have? 2 bromo pentane. So in all cases, what you see, this one is how many degrees, guys? This is 3 degree. This is 1 degree. This is. So I think we know the answer. Right. So answer is three increasing order they're telling, right? So 1 degree, then 2 degree, and then you write for 3 degree. Okay, clear for everyone who's attending online? Offline, did you all your answers are like this? Online? Raise your hand who got correct answer. Okay, good. Tanvi. Avantika also got correct. Good to see. Okay, so many people. Shreya, Pranav, and Tanuj. What about you guys? Pranav, what about you? Okay. Shreya and Tanuj, what about you guys? Does your answer match with my answer? Okay. And in the second case, again, let's draw the structure. Okay, this is how you have to approach in the exam. Okay. So here you can see in this case, 1 bromo, 3 methyl butane. So there is going to be a bromo and this is your methyl. Okay, so this is how many degree? 1 degree. Next you have 2 bromo, 2 methyl butane. So this is how many degree? 3 degree. And finally, what is the last one? 2 bromo, 3 methyl. So this is how many degree? So I think we got the answer for this one also. That is 1 degree, then 2 degree, and then increasing order. How many people got this one correct? Raise your hand online. Okay, good. Diya, Shreya, Ananya, Pranav, Aditya. Okay, good to see that. Diya, what about you? Okay, you also got it. All right, so that means mission successful. Okay, for SN1, SN2 reactions, make sure whatever we have done till now in haloalkane halogens, you need to revise because now we will see more chemical reactions of haloalkanes. And we can say there's nothing wrong to say that tomorrow we will finish haloalkane and after that halorine we will do. All right. And in weekend, you all have to attend the class IUPAC naming. The last part I will discuss. I think we started with complex substituents, right? There are few more things which I have to tell you. Okay, but that functional groups. All right. All right. Bye, guys. So good night, everyone, and let's meet tomorrow. Yep. Yeah. Bye.